and get started. I'd like to welcome you everyone to Ignite Your Curiosity. I'm Paige Lovren, your host tonight, representing the Visalia Unified's College and Career Readiness. Ignite Your Curiosity will be a monthly series of webinars for students and parents to hear from a variety of industry leaders. Each month, a new industry-themed panel will help you explore different career possibilities with your child. This month's theme is STEM, Science, Technology, Engineering, and Math, as we welcome PhD candidates from Harvard and MIT. I'm going to cover some basic housekeeping information before we start. We're going to be placing all participants on mute, but you will be able to submit your questions utilizing the Q&A feature at the bottom of your screen. We will not use the chat and raise your hand feature tonight, so please direct all questions to the Q&A. Tonight's webinar is being recorded, and tomorrow it will be posted to our website. So I would recommend that you, so that you can easily find our website, is to either take a screenshot or a picture of the screen right now. This is our website address, and it contains a broad range of college and career, CTE, and Linked Learning Academy information. It's definitely worth your time to explore, and we will be growing this website in the upcoming months. Finally, before we begin, don't forget to keep checking with our newsletters this year for upcoming events like tonight's. These newsletters are sent out by email and are also accessible on our website. Okay. And now I'd like to introduce our MC, Visalia Unified's Coordinator for Science and Math Curriculum, Jill Billingsley, along with our panelists. We have Bolu Pokoya, who completed his Bachelor of Science at Swarthmore College and is currently a student and PhD candidate studying microbiology and infectious disease at Harvard Medical School. We often have Megan Castle, who has also completed her undergraduate degree from Swarthmore College and is currently a graduate student PhD candidate studying protein biochemistry at MIT. We also have Kevin Dervishi, who completed his bachelor's degree at UC Santa Barbara, was a Goldwater Scholar, and is currently a graduate student PhD candidate studying cancer biology at Harvard Medical School. So with that, let's go ahead and get started.
Hey, well, welcome everyone. So I'll be your MC tonight, and I'll be asking some questions of our panelists. And then as we go through the night, you can put some questions in the Q&A, and we'll go ahead and answer those as we move through the evening. So the first thing I'd like to do is just kind of throw this out to the panelists. Just kind of give me, what is your educational background? Just a little background about yourself as we kind of get started.
I'll go ahead and kick us off. So I grew up in San Diego, California, Southern California, born and raised. And that was when I started to get interested in biology, took some classes in high school that I was really interested in. And then I went off to college at UC Santa Barbara, which some of you may have heard of. It's one of the schools in the UC system in California, and they had a really phenomenal biology program that I heard about in high school. And I was like, you know, this seems like it'll be really good for me. I want to give biology a try. And so I went and got my bachelor's in biology at UCSB. And then I decided to continue onward. And now I'm here at Harvard trying to get my PhD in cancer biology.
Okay, I'm Megan. I grew up in Fort Worth, Texas, and I similarly became interested in biology and chemistry. I was really into animals, and that was actually why I got into biology, just because I loved animals so much and I wanted to find out more about them. And I also had some really good chemistry teachers in high school that I really liked taking their classes. And so after that, I ended up going to Swarthmore College, which is in Philadelphia. And I got a bachelor's in biochemistry and a bachelor's in Spanish there, and then moved up to Boston to attend graduate school at MIT, and I'm studying protein biochemistry now.
Hi everyone, I'm Bolu. I grew up in Nigeria, and I was actually homeschooled for quite a while, and then I didn't really know that I wanted to study biology when I got into college at Swarthmore College. But I knew I wanted to study diseases and human health. And so I actually did a lot of work studying anthropology and the humanities, and then realized how much I liked biology and chemistry when I started doing more biology and chemistry, taking those classes, taking those labs. So I graduated from Swarthmore with degrees in anthropology and biology. And now I'm here at Harvard Med studying infectious diseases and working on vaccine design.
Great, thank you for all your great background. One of the things is because I'm kind of into the science world, and things early on in my life drew me to science. Like I still remember my dad giving me a marine biology book when I was 3 years old. And right then I knew I wanted to be a biologist. So do you have any of those kind of stories, like what drew you to science?
Megan?
Sure. For me, as I kind of alluded to earlier, I loved going to the zoo growing up, and I would occasionally go to some zoo camps, which really just meant you got to color things and walk around the zoo. But it allowed me as a kid to really start to learn about animals, and that made me want to be a vet, actually, a veterinarian. And then I realized that you have to do surgery on animals if you're a veterinarian, and I didn't want to do that. So that was kind of like my entry into science and into biology, just thinking about organisms and thinking about biology in terms of the way animals interact with each other. And then as I got older and started taking biology courses, I learned more about smaller things and like bacteria. So those are just even smaller organisms. And then I realized that bacteria have protein in them too, and proteins are really cool as well. So it kind of just turned into this funnel once I realized that I really liked thinking about the way the world works around us.
Yeah, no, I think I really started thinking a lot about biology and about human health because I used to love watching nature documentaries. As a child, I would like just sit down and like watch all these things about jungles and about the desert. And then I remember this one episode about cities and urban environments being places where biology is happening and there is nature. And so that got me really thinking about where social studies and studying cities and studying people and movement also meets with how diseases spread and how illnesses spread and how we can prevent them. And so when I started thinking about what I wanted to study more in college, I focused on where those two met, which was public health. And then in particular, when I was looking at what I wanted to do in grad school, I specifically wanted to study infectious diseases that impacted parts of the world that I grew up in and I come from. So in Nigeria, you see higher rates of certain transmittable diseases, and I wanted to study those. And so now I spend most of my time studying cholera, which is a bacterial pathogen, and making vaccines for the next generation of cholera vaccines.
I actually had a pretty similar story to Jim where, early on, I read through a lot of books on like sea life and marine animals. And initially I was just really blown away by all the different life the different forms of life that there are in the ocean. And being in San Diego, we're a coastal town. And so it was just kind of on my mind a lot. I was really excited about it. And the more I thought about it and the older I got, the more I realized that what excited me about biology and studying like life itself is not necessarily the large scale stuff, which is an entire field of biology, is like ecology and all that. But what really interested me was kind of the more small scale building block of stuff. How does this work on a molecular level when you have to look at it under a microscope or even beyond the level of a microscope? What is happening that makes things behave the way that they do? And that was what really excited me. And that's why when I decided to go to college, I took a lot of classes that just really interested me and ended up, focusing on biochemistry. And that was kind of my focus in college, and my emphasis in my degree was biochemistry, because the fusion of those two fields was just really fascinating.
Yeah, I completely agree. And it kind of sounds like what our similar story is. We have a lot of curiosity. We want to find the answers to things, and that kind of drives us. It's kind of what I'm kind of seeing. So kind of when you got your undergrad degree and then you're on your way to go to grad school, what is the process to apply to grad school?
Yeah, sure. So for me, I was applying to grad school coming straight out of undergrad. And so there I was able to contact different professors who I built up good relationships with over time, and I'd taken their classes, I'd done some work with them, and they primarily wrote these recommendations for me that said that I was able to do certain things and that I had these certain skills that would be well suited for a grad school environment. The application itself was a couple of essays and some personal statements, a transcript of my undergrad studies, as well as the things that I had done outside of the classroom. So what were the extracurriculars I was engaged in? And in particular, I have always loved teaching and teaching classes, big, like large classes, small classes. So a lot of my application was focused on how I was going to take what I was learning in grad school and apply that to becoming a teacher in the future. Beyond that, there's a resume portion, and some schools do require tests, but there are new guidelines on how test scores are taken into account at the end of your college when you're applying to grad school.
Mm-hmm. And one thing that Bolu kind of hinted at that is important for applying to grad school is having some research experience. And so that's something that you can do when you're in college, either over the summers, or if you're at a college that has research opportunities on the location, you can contact a professor. Basically, you just send them an email and you say, hey, I think your research is really cool. Do you think that I could come by and talk to you about it and potentially have a spot in your lab to do some work? And so that's really how you get your training in college to be able to go to graduate school.
I think Bolu and Megan explained it wonderfully, and there's not too much I would like to add to that except for perhaps the letters of recommendation. So you need usually around 3 letters of recommendation when you're applying to graduate school, and these can be from a variety of people, but it's typically professors or people who you have worked under, you've done research for. And for me, that was a really big deal because it really gave me a chance to just kind of reflect on the previous 4 years and say, you know, these are the people that I've met, the people that I've worked for who know me well. And it made me honestly really grateful for the fact that I went into this program that had a lot of really great people with really great mentorship and opportunities. And that is easily kind of one of the biggest parts of your application for graduate school is these letters of recommendation. And so having that kind of panel of people that I could go to was a big part of it.
I'm going to interrupt real quick. We're having a request from the audience to speak just a little louder. Also from the audience, if you can turn your volume up to full volume, that'll help too. Thank you.
All right, so you mentioned about letters of rec and those kind of things. And so when kind of working to that, how important is it to work with others in order to get those things, you know, like internships, undergraduate research? How important is that to kind of get you to the next level?
It's probably the most key thing that you can do is to make connections, to do this kind of networking. I mean, that's how we know each other, just by going to each other and being like, hey, I think your work is really cool. Like, can you tell me more about it? And now I can be like, hey, Kevin, can you tell me about that one protocol that I need to work on? Because I need help doing this. And so basically at every stage of the process, making connections and talking to people is going to get you where you need to go. And scientists, like, maybe we have a reputation for being nerdy, but everyone loves to talk to everyone. Like, we love to talk about our science. So if anyone ever comes up to us, we could talk your ear off all day.
I think you also just mentioned something that really defined who I asked to write letters of rec for me, which is, for me, a major moment was learning when to ask for help in classes. So I didn't have the strongest math background in college, and I struggled a little bit in physics, but the professors that I went to their office hours and I said, hey, I would really like some help, and they were able to see that I was really trying hard and putting in the effort, and that showed them that I was wanting to learn and wanting to engage. And so being able to ask for help was like a really big thing for me, like learning in college and also in grad school now. Like, a lot of the experiments don't work right off the bat. And so it's always a question of, well, who can I go to who knows how to make this work? And then we can collaborate and work together on things like that.
And one thing that I want to point out is, and Bolu mentioned it, is office hours. It makes such a big difference, not just for Bolu, but for myself also. My math background was also not the strongest when I got to college, but also my chemistry background wasn't the best when I got to college. My high school didn't have APs, so there was a lot to work with there. And going to office hours made a world of difference, not just for my performance in class. Like, yeah, I was way less anxious about the homework and the tests because I got to talk to the professors, like one-on-one most of the time. That was great. But what was really valuable was what you just asked about, Jim, was the networking opportunities. that's where I really got to know my professors, especially, you know, my school in particular. I don't know if this was your guys' experience, but at my school, you know, the class sizes were really, really large. There were hundreds of people in class. And even in a smaller class setting, you know, when you go to office hours and you get to talk to the professor one-on-one, it makes such a difference in how you get to know them. And so for me, that was easily, I'm so glad Bolu mentioned that. It was like the #1 thing that I benefited from in college.
Yeah, I'll definitely agree with you on that one, having that personal connection with your professors. I'm a graduate of Cal Poly San Luis Obispo and within biochemistry and microbiology, and those classes are typically somewhere in between 15 to 20 students. And so you've got really good connections there, and they would hook us up with research opportunities, with internships, and it's that whole learn by doing. Instead of sticking your nose into a book, it's really going out there and doing the research and actually doing the science is kind of the big key. So thanks for sharing that. That was good.
And something that kind of is we're not saying it directly, but I want to say it directly, is that you don't have to be the person who gets it right away or the person who just immediately understands how science works. What matters is that you're passionate about it and that you are truly interested in learning, because there will be so many people who want to help you, and learning how to ask for the help is going to be really important for your growth there as well.
Yeah, completely agree. I always, struggled a little bit in school, but then I was always kept trying, and you just find those professors and those teachers out there that will help you and support you and kind of move you on. So that kind of leads us into a question, like within your research possibly, or maybe undergrad, what's some of your biggest frustrations that you've encountered? And then like, how did you overcome them?
I think specifically with research, and it's not a past frustration. It's something that it's still ongoing. Is that I'm unlearning a lot of bad habits that I built up over the years, specifically about writing things down, keeping a record that I can go back to and see what I've done in the past, so that I'm not making the same mistakes again. And a key example of that is even now, like in grad school, I'll do an experiment and I'll wonder, why is this not happening the way I think it will happen? When it turns out I did this experiment 3 months ago, saw that it didn't work and didn't write it down. So those are things that I'm teaching myself to actually slow down, write it down. It may take a little bit longer, but it is so, so worth it, both as a record for myself, but also to share where I've had successes and failures with other people. And that's something that I think I'm learning not only in my science and in my experiments, but also in just like my learning in general. Like sometimes I get so excited about learning something and I just want to read the textbooks and read the newspapers, but taking stock of what I'm actually learning so that it remains in my brain is something that is a frustration, but also I know I'm getting better at doing.
For me personally, I would say that the biggest thing was in research, and Bolu kind of hinted at this earlier, was, when you try an experiment, it's almost guaranteed not going to work the first time. And I think that is something that can really hit you hard when you grow up your whole life and you see all these really cool movies and TV shows and books where they're like doing all these cool things in the lab, and you realize it takes a lot of work and time to get to that point. And it kind of hits you in your tracks because you might have taken a lot of classes on the subject and felt really good in class and aced that exam, and then you're like, why can I not get this basic experiment to work? I've tried it 5 times this week. Please, oh God, please work. And that is a point of frustration. And honestly, I think the biggest thing was having peers, people like Megan and Bolu, who I can talk to and be like, yo, I tried this and it didn't work. Does this seem weird to you? And to ask friends about that, both peers who are going through the same thing, or people above us, like professors or other mentors who have finished their PhDs and can say, like, listen, I've made this same exact mistake before. Here's what you're doing. Those have been such critical parts of the mentorship that I've gotten, and it makes a world of difference. Otherwise, the frustration would have been so much harder to deal with.
Jim, can I jump in?
Go ahead.
I'm sorry, can I jump in and just remind the audience, if you have questions along the way, please go to the Q&A and put questions in the Q&A, and we can direct that towards our panelists.
Okay.
I'll comment on something like college related, I guess, then, because research is very like, it is up and down a lot of the times, but I think that you get so much out of it, like learning about yourself too. But for me, something that I found kind of frustrating was when you go through college, you're expected to take classes in like 10 different subjects, but maybe like the one you really want to study is just one of those 10. And so it can be a bit frustrating sometimes to think like, oh, well, I'm not doing well in this course, but you're doing really well in the other one. But actually, it's really just helping you narrow down what exactly you're interested in. So my degree in chemistry, I'm only doing biochemistry now, but I learned all about physical chemistry and organic chemistry, and I found it incredibly difficult, but it allowed me to like learn about those fields. At the time, it was very frustrating, but now like when I'm doing my project, I can see how all those things tie together. And so I think like it's something that it's a frustration you have to work through as you're going through that process. And in biology as well, like there's microbiology, there's cancer, there's aging, there's plants, there's so many other things, right? And until you find that one thing that's like going to be your thing, I think, you know, it can be kind of hard sometimes, but it's definitely worth it.
Great, which kind of leads me to another question is, you know, how did you choose your area of research, or was it chosen for you possibly?
It was a bit of a lucking into it, let's say, because so Swarthmore is a really small school, and there was actually only one biochemistry professor in the chemistry department when I attended. It's now a little bit bigger. But as I mentioned earlier, when you email professors to ask for research opportunities, I basically was like, oh, I think I like biochemistry. I think I'll email Dr. Miller. And I emailed him asking if I could learn more about his research. And he happened to study protein crystallography, which is a method that you can use to look at proteins. So basically you can figure out what proteins look like, their structure on a molecular level. So you can see the amino acids and you can see exactly how they're twisted and folded together. And that's why I say I lucked into it, because I was like, wow, this is so cool. Like I've always thought, how do these things work? Like, how does this tiny little protein do what it's supposed to do? And that really got me down this pathway. And I said, okay, I think I want to keep studying proteins in graduate school. But this time I'm going to look at how they function rather than like what they look like. So it really got me into the field of protein biochemistry just by chance, but I love it.
I had a very similar experience to you, wherein I took a class in college, and it wasn't even a class that I was looking forward to. I think the one I wanted to get into had been like filled up. And so I signed up for this microbiology class. And I think the cool thing about microbiology for me is that it seems really small. Like the bacteria I study are incredibly tiny. You can fit thousands upon thousands on the end of a pin, but they are so important. Bacteria shape our climates. They shape what we consider food. They shape the landscape. And when I really thought a bit more about what kind of stuff I wanted to learn about bacteria, I really wanted to see what made some bacteria bad and cause disease, and what makes some bacteria good and they help us digest our food, and they help us create new fuels for the future. And so when I was coming into grad school, I really wanted to focus on how people interact with bacteria, specifically disease-causing bacteria. And I also wanted to focus more narrowly on diseases that I knew had these really large human impacts all around the world. So these are tropical diseases. I did some work in malaria and some work in tuberculosis, but the current lab I'm in now studies cholera, which is this pathogen that is really quite devastating. But as we learn more about it, we can create new therapies and new vaccines to prevent future instances of it.
So we do have some good questions coming in, so I'm going to pop a couple of those questions in and then let you continue from there. So let me read a couple of them off, and then you can address them kind of maybe simultaneously. So we have one student asking, he's thinking about applying to Harvard as an undergrad, but was wondering if it would be better to apply Harvard for grad school instead, especially since it's out of state, and go to a UC or state school. So that's one question. And Kevin, that's probably one for you to address, especially with UC Santa Barbara. I have another great question is, what advice would you give to high school students regarding study habits and skills you need to be successful? Another student is asking if you're concerned if artificial intelligence would take over your career and how that human element stays in there. And then another question we have also is, how could a middle school or high school student explore their options and find their passion? So maybe we can start with Harvard, graduate school or undergrad?
Well, bearing in mind that I am not a high school counselor, but here's the best advice I can give. I think that the most important thing is recognizing what matters most to you and your own education and your path through your education. When I was in college and applying to graduate schools like Harvard, there were a lot of peers who were also applying to Harvard for graduate school and had gone through very different paths. So if you are worried about finances, and that's something that you really want to kind of prioritize, I know people who went to state schools like myself. That was part of the reason why I really liked the state schools that I applied to, because they had great programs, but they were also a really great way for me to not go super duper in debt when I was trying to get my bachelor's. One really neat thing that they don't always tell you about graduate school is if you're applying to get a PhD, especially in the sciences, you will almost always get paid to go to school. So we, not only do we not pay tuition,
They pay us.
they pay us, which is pretty cool. If you walked into class in high school and your teacher hands you money, that's kind of weird, but it's a normal thing in your PhD. That happens for pretty much all of us. So, that is kind of one path you can take. I will say, I think there are a lot of different paths you can take. Some people have, gone to community college for a couple of years before transferring into a state school to really just save the cash that they want to save going to graduate school. I think the main thing I would recommend is just talking with a high school counselor and using that mentorship to see what your best options are, because also applying to Harvard for undergrad, a lot of undergrads do get financial aid at Harvard, and that can also kind of ease that. So that's the biggest piece of advice I would give, is just look at your situation and what is most important to you, and then talk with someone who has experience in that, like a high school counselor, and see how they can help you reach those goals in a way that meets what's most important to you.
And add on to that is it doesn't only matter where you went to school. We've talked about research, we've talked about letters of rec. Those are extremely important. And so if you go to a state school and you do research and you are working really hard, that is going to be really important for your graduate school application as well. You could go to Harvard and not do research. Well, you're not going to get into Harvard graduate school, right? So it's not only about where you go to college, it's what you make of it.
Absolutely.
How about the advice on study skills and things that you need to be successful, that you can practice in high school in order to be successful in college?
You probably have, especially being homeschooled.
Yeah, I think Kevin kind of spoke to this earlier, but the study skills, I think that really helped me a lot in grad school and also throughout college, was finding motivation when things were not necessarily going well. And so finding something that I really enjoyed doing, that I really wanted to learn more about, and using that to fuel my other subjects. So for example, I was really, really interested in microbiology, but it turns out you have to know a good amount of biochemistry to be able to understand microbiology. And so I was able to take my passion, my motivation from microbiology, and use it to make me continue to put in the effort and put in the time for the other subjects that require that kind of attention. I've spoken about this a little bit more, but finding a system that works for you for keeping track of what you've done and the things that you are good at, because the more you work at something, the more I work at something, the more I realize that I'm getting better at it. And it's good for me to have this sort of portfolio that I can show, this is where I started, this is where I am now. I've clearly been able to grow in this skill. So finding a system that works for you, whether it's keeping a notepad or a journal, or writing summaries of the things that you're doing, because those will be so critical when it comes to being able to apply for a job or write an application for grad school, because being able to track that progress is really important. And then again, the other thing that was really, I was homeschooled through high school, and so going into college, I definitely thought, you know, like I can do this myself. Like I've already made it this far, everything's, and a lot of the way that the college I went to was designed was to encourage students to learn how to ask for help, how to seek opportunities for assistance, and
to work together.
And to work together, yeah, to find the people who I want to surround myself with, because I know we'll help each other be better students. And so whether that means going to this help sessions after class and making time for those, forming study groups, office hours, and going to faculty who genuinely want to help students. Like I didn't know how to write a lab report when I got into college, and now I write lab reports every day. And a lot of that is A, some of the classes I took, but also B, the biology faculty member who sat me down and we were able to walk through what are the key components of a lab report. So I know these things. So yeah, I think those are the three main things that I would say you can begin working on in high school and in middle school to be able to, successful study habits.
Probably the biggest thing for me that took me way too long to learn was that it's really good to talk about and do your work with other people, because sometimes you think you understand something, but until you actually have to vocalize it and talk about it with a friend, and maybe they ask you a question and you think, wait a minute, I actually don't know how this works. Let's go through it together. So I wish that in high school, I was really independent in high school in terms of doing my homework. I wish that I had had a study buddy, or at least someone that I could bounce ideas off. And it wasn't until kind of late in college and in graduate school that I learned I do really need someone to help me work through problems, because I can't figure it out all on my own.
Okay.
We got, oh, sorry.
No, go ahead.
We got a lot of really good questions from the chat. Could you remind us of some of the ones that came up, Paige?
So maybe Megan, you were talking about seeing crystals on a level that we can't see with the human eye. Are you concerned about AI taking over your job someday?
So it's true that a lot of things are becoming automated. However, I think at the point where we're at, it's actually become more helpful, because what it used to be to make a PhD would be what I did in like 3 months in my college. So that means that we can see and learn so much more. And what AI at this point will never be able to do is think like a human being in terms of planning experiments, understanding how this body of research and my friend Kevin and my other friend Bolu, their research, and they're telling me this information, how that all fits in together. And sometimes experiments don't work even though they should on paper. And a computer doesn't know how to solve that problem, right? Because they're very logical. So I think it's actually the way that AI and technology is working right now is really helping in a lot of ways, and we can accomplish so much more on any given day or week or month in our PhD than even just 10, 15, 20 years ago.
I think that is such a good point. Tell me if you disagree, either of you, but I think there has never been as exciting a time to be in biology as right now. It just keeps getting more exciting. And a large part of that is because of AI, for exactly the reasons that Megan mentioned. There are so many things that we can do now that in the past, people would have to be so careful about designing these things themselves. I can just go online to a website and say, design this DNA to cut this other piece of DNA for me, and just do it in this region of the DNA. Like I don't have to, I have to understand conceptually what's happening, but the AI is not getting in my way or replacing me. It is allowing me to instead just blast through things that used to take so long and do more in the same amount of time. It's really exciting.
I think something that Kevin said that like resonated with me is the element of design. Like as much as science is rigorous and we're constantly using very specialized techniques and protocols, there is a large creative element of doing the kind of science that we do. Like some of the advances that have been made in biology and in medicine have become because someone had a really brilliant idea and also really innovative and creative way to approach that idea. And when those sorts of things happen, and that does really require a human element, a human touch, you can start entire new fields, entire new industries, because there's that element of creativity and design in there that I think we're using AI to help us get better at doing that. But there is still a lot of human interaction that's required for that.
Great. Kind of going through some of these other questions. Let's see here. Oh, how long did it take to get your major, like undergrad?
4 years.
4 years.
4 years. 4 years, yeah.
I know people who took 5 or longer, or some people who did it quicker. I think 4 years is a pretty standard amount of time, but there's definitely reasons why it could take a little bit more time. Like if you wanted to get more research experience, for example, and you took a semester and you did that, that's something, some schools even build that into the curriculum, where some universities like Northeastern does it. So Northeastern in Boston is a school that, for example, they have these co-ops that you go and you do research or you do work for 1 semester, and that tends to make your undergraduate a bit longer, but you get more job experience basically.
That makes sense. Let's see, another question kind of out there. How should a middle school or high school student explore their options and find their passion? So what do you think about middle school, high school, looking for passions for career, college?
Maybe this isn't the answer that the adults want me to say, but social media has a lot. No, but I'm serious. Like there's so much, like there's so many cool scientists on Twitter, TikTok, like there's some really cool people who are trying to make educational, information out there that's like more accessible to people. And if you see something like in a TikTok that sounds really cool, then I encourage you to just Google it and like try to find out some more information on Wikipedia. Or if you see a paper that looks interesting that you want to read, you can look at the figures. And so I think social media nowadays is a really good way to start networking. Not that you need to network when you're like 14 years old, but you start to get an idea of what you like to do when you start immersing yourself in the world of science.
I think the biggest piece of advice I can probably give, particularly with science, but in general, I think just asking questions. Usually if you are engaged in something, if you're doing some activity, if you're working in a lab or in a class, you're around somebody who can teach you something that you don't know. And as a teacher, as a mentor, like it is important to me to mentor and help everyone that I meet, but in particular, when I know someone is interested, when they're asking questions, when they are showing that this is something that they care about, then I feel like, okay, I'm not just harassing them with information about biology, like, hey, do you want to know about DNA? You know, if I see they're interested, it makes it so much easier to give them any support I have to offer. And so that's what I would say as a middle schooler or high schooler. It's never too early to start asking questions.
Yeah, I think something that Megan said that struck me is that like there are so many ways that you can get involved with biology and science now, and a lot of them are useful for scientists. And so if you're really interested in writing and you want to write more about science, and please do. People who have blogs or who have online presences talking about the things they're interested in. I remember some friends of mine from back home when we were younger used to write a blog series about global health and the questions that they had and what they were reading. I know people who right now are getting their PhDs because they want to write about science, because they want to be the ones who are providing information to the general public. And so they're learning how to do science so they can communicate it better. There are some people who are really interested in drawing and visual arts and being able to create content that explains a concept that's particularly difficult. And if that's something you're interested in doing, then there are really great resources online or in libraries for how science illustration works and why scientists find those skills very valuable. If you're someone who's really into math and is really good at organizing Excel spreadsheets or knows how to navigate that, those are skills that are extremely in demand now, because as Kevin was saying earlier, the amount of information that we're generating right now is really quite difficult to navigate and to deal with. And so people who have good intuition when it comes to how do you handle a spreadsheet or how do you handle lots of data, and how can you, and those are skills that you can build in math and you can build in other computer-based learning. So it's not only being in a lab that counts as science. Everything involved that surrounds science, that allows science to continue, and specifically biology, because it's so exciting right now, they're all super valuable and they're all things you can do from middle and high school.
Yep. Completely agree with you on that one. Let's see, a couple other questions. How can I prepare for MIT if I'm in middle school?
Okay, MIT if you're in middle school. I mean, I think, you know, we've talked a lot about just showing that you're engaged. If you truly are passionate about something, talking to the person who's teaching you. So your teachers are there because they want to teach you and they love the subjects they're teaching, right? And showing them how interested you are, asking questions, following up on your own time too. I think, you know, you're going to learn something in class, and if you find it super interesting, write it down and go look it up later. Look it up in a book or on the internet and try to find out more about it, and you'll see how quickly the circle will expand. And as you do that, you're going to find what you're truly passionate about. And you know, there's no trick about getting into MIT or Harvard. I think, you know, we've hit on this a few times, but it's really just showing your passion, getting the experience in. So it doesn't have to be lab research. It could be computer science. So you could do computer science biology and never step foot in a lab. Or you could do something like illustration, but showing that you have the passion and you are willing to work, and then making connections with your professors who will write letters of recommendation for you. Those are going to be the really big ones. And obviously study hard and, you know, take your classes seriously. But, you know, I think that the way that admissions work is a lot more personal than you might think. And so if you have a really strong personal story to tell, or if you have a really strong mentor who can write a really great letter to make you stand out, then those are going to be the things that will get you the foot up as well.
Okay, let's see here. What else? What one thing of advice would you give to a high school student who doesn't have an identified goal or direction?
I think it's fine if you don't now. I think there's a lot of pressure to figure out what you want to do. I think Yobolu already talked about not knowing what he wanted to do when he got to college. And that's true of a lot of people. Certain schools will be a bit more amenable to this than others. So for example, Bolu, in my experience at Swarthmore, it's a liberal arts school, which means that you are encouraged to kind of sample a bunch of classes before you really decide where you want to focus in on your major. And so if that's something you're really undecided, there are liberal arts schools all over the country. And this is something I didn't know. When I was applying to schools, I literally like Googled liberal arts schools USA. Like I didn't like, I was like, how do you find this, you know? And it's not something I knew before I went to Swarthmore either, but they're all over the country, and they'll get you the kind of experience where similar to Jim, where there's, you know, fewer than 15 people in your class. And so you can start to get to know people, and you'll start finding the things that you're passionate about. And it could come out of nowhere. And maybe you are able to, when you're old and 25 like us, you'll look back and say, hey, that was that thing that really got me down this pathway.
One key piece of advice I would give is just look at whatever colleges are interesting to you and see if they have an undeclared major and how flexible they are with that. There are so many colleges that are liberal arts and are extremely flexible and give you that kind of freedom, but also even outside of liberal arts schools, at my like fairly standard state school, you could be undeclared, which means pretty much exactly what our question asker just said, right? Like you're not entirely sure of what kind of clear goal you want to work towards. You just know that you want to continue your education, you want to see what's out there, you want to explore. And at UCSB, you could be undeclared for, I think, 2 years, which is half of your college education. You could spend half of your time in college exploring things and figuring that out. So
that's like 16 classes that you can take
yeah,
before you even decide what you want to do.
Exactly. So I guess that's kind of my biggest piece of advice is don't feel too panicked if you know you don't have some exact field or idea that you're excited about. If you want to explore, that in itself is a really great goal to work towards.
Yeah, I guess for me, the one thing, or the two things I think about are, one, not being afraid to try something new. Like college, there are so many things you can learn in college. There's so many classes you can take. There's so many options, and that feeds. So don't be afraid to, like, I know I took a lot of chemistry at Swarthmore that I was not planning on taking because I was like, well, what if I did this some more? And what if I did this? And there's some parts of it that I really, really liked, and other parts I learned from them. And that comes to the second part, which is even if you're trying something new or something you weren't expecting, I wasn't expecting, take some time to figure out what you learned from that experience, because there is no way you can take a college class or you can take a dance class that you take or an internship or a program and not have grown in some way or learned something about yourself or learned something in general. So I think my first year of college, I took a class in Japanese calligraphy, and what that got me to do is I learned a ton of patience in the art of like being able to go back and revise and learn how to make something better with each time I did it. And so even though I don't do calligraphy anymore, it's something that I took a risk on. I went out and I tried something new and I learned a skill from it. And that's something that you can do no matter what class you're taking. So being able to identify what that area of growth is, and again, like write it down and keep a track record of those things.
Yeah, great advice. A couple questions here about majors undergrad. So one of them is, did any of you ever change your major? How difficult was it to change your major? And do you think it's a good idea to maybe have a backup major when you go into undergrad? I don't know, a lot of questions there.
I never changed mine. So it's pretty much just paperwork, depending on where you're at in the process. At Swarthmore as well, you don't have to actually declare a major, and this is true for a bunch of schools. You don't actually have to declare a major right when you get there. You can wait a little bit, and even if you do have to, as you're applying, you can change that. It's not binding. You just want to make sure you're really sure what the requirements are. So that's where when you get to college, they'll assign you an advisor, and that's where you have conversations with your advisor, and they'll be able to say, okay, you need to take these 4 classes, and then you can get this major or this minor. And they'll say, okay, now fill out this paperwork, which I guess paperwork is now an antiquated term because it's probably all online nowadays in terms of adding and dropping and changing classes. But it's not something you should worry about right now at all.
So I technically changed my major, but I changed it from a biology degree to a slightly different biology degree. But there was kind of a process there, and it is something that I was thinking about a lot, which is I asked myself every day, am I still enjoying this? Do I want to keep doing this? And that was just something that I heard when I was in college. And I took that advice to heart, and I'm really glad I did, because it made me feel a lot better about sticking to biology, such that I ended up changing to a different bio major because it was one that was way more focused on doing research. It wasn't so much like, oh, I might want to go to medical school, or I might want to just like graduate and work for a biotech. It's like, no, I want to do research. I want to go to graduate school and earn a PhD. And by switching to that program, it made a huge difference for me. And I would only have done that by reflecting every day like I did and saying, do I want to keep doing this? Where do I want to take this? And I never had the answer, right? Mm-hmm. Like most days I was like, I think this is good. I think I'm liking it. And it's just something that you kind of continue on, you expand on it. You're not going to have the answer like one day. It's a process over a course of days, weeks, months, where you realize, yeah, I do like this. My answer is still yes.
I did not know that about you, but I realized it's also the exact same reason why I added in a major in anthropology. Like I took a class my first semester fall, and it was an intro class. There were some really great readings. There were great discussions, and I thought, okay, I'm liking this. I'll do this again in the spring. And then I said, wow, I really like this. I'll do it again. And I kept doing it. And you know what? And I knew that like when I looked back on my college experience, I wanted it to be as much about the biology and the chemistry and the math that I was doing, but also about the discussions about readings from all over the world that I had with my friends. And we wrote theses, or we did some really in-depth analyses on these social things that were happening and these social issues. And I'm in grad school now for microbiology and infectious diseases, but in undergrad, I wrote my thesis on Black men's hair because I really wanted to spend some time thinking about how do people in society think about hair and about race. And so things like that, like if you are enjoying it, I learned a ton about how to write and how to analyze the literature. I learned research skills. I learned how to communicate my findings, mostly through my anthropology major. And here I am in infectious diseases.
No, but that's such an important point though, that we should say explicitly, is that like, so much of this is about skills, not necessarily the facts that you learn. And it's about taking the classes and doing the things that are going to get you the skill set that will allow you to go to graduate school. So learning how to write and learning how to analyze data, learning how to ask questions and design experiments. Those are things you can learn in many different fields. It doesn't have to be biology.
Yeah, that's a very, very good point. Let's see, kind of another question. Do you have to have a GPA of a 4.0 to get into MIT or Harvard?
I did not.
I did not.
I did not. Definitely did not.
So like,
I didn't have a 4.0 getting into Swarthmore either. So
Yeah.
So so if you don't have to have the 4.0, what do you think are the important aspects of a high school resume to help get into a good undergrad school?
So I think for me personally, I really struggled with some of my classes in high school. My GPA was not a 4.0. The thing that really made a world of difference for me was two things. One, extracurriculars, right? Like, that's a beautiful word. I had things outside of class that kept me sane, and not only kept me sane, but taught me some of the most important lessons I learned during high school. And they say this about college, right? Where you'll learn as much, if not more, outside of the classroom as you will inside the classroom. And I think as time goes on and our society gets more and more educated, you all in high school and even middle school are having more chances to kind of get that hands-on experience outside the classroom, to do research internships and do all these different things. And there's no one way to go about it, but having something outside of the classroom that you can talk about when you're applying to college that shows you have an interest, you are so much more than the numbers that like come on your application. And being able to talk about those experiences make a world of difference.
yeah, and it also, to make clear, it doesn't have to be experiences in the thing you're interested in either. So like I did a lot of sports, and I think, you know, you can write a whole essay about what sports teaches you and how you're going to use those skill sets in your college education. If you have to work a job to help support your family, you can learn a ton, obviously, at your job. And they want to see basically that you're thinking about what you're doing critically, and you're not just jumping from one thing to another in terms of, you think, oh, if I have one semester of student council on my transcript, it'll look good, or on my resume, it'll look good. What they want to see is that you're finding something and you're investing time into it, and you're reflecting on it and able to say, what did I actually gain from this process? What experiences did I have that are going to bring me into college where I can succeed?
Yeah, and then even as you're going from college to grad school, like as much as my application to Harvard included my coursework and my transcript, I spent a lot of time talking about how much I like teaching, because I really did, and I really do. I like the idea of being able to share ideas with students. And as a teacher, I learned so much every single class that I teach, right? And so that experience is something that I knew I wanted to do more of, and I wanted to get a PhD to be able to continue doing. And that I wrote a lot about, because it wasn't necessarily a GPA, it wasn't a list of classes, but it was it was a driving factor that I had, that I knew would be, that I knew I enjoyed doing, I could talk at length about. And so, yeah, your application is especially nowadays, a lot more than your GPA. I had some classes in college that I did not do well in. And after those classes, I went to the professor and I said, hey, can we discuss what happened? And either I took another class with that professor and I did better in that class, or in one instance, the class I did pretty badly, and the professor wrote me a letter of rec saying that, like, I really tried hard. And I know I tried hard. Like, I'm proud of the grade that I got, because it was a struggle. And so being able to find, again, like, what are the moments that really were moments for growth, be they in the classroom, in the extracurriculars, and the jobs you're working, and the things you like doing, and then writing about those and conveying that well.
Great. Yeah. So one more question here, it looks like. Let's say, see, if you change your major, does it take another 4 or 5 years on top of that?
No,
So,
maybe if you're your last year of college and you want to decide you want to start all over, it would take another 4 years. But no, definitely not. So majors generally, probably like 8 to 10 classes. depending on what major you're doing and what school you're at, and what kind of prerequisite courses. So any course you need to take that will help you in the next level course that you have to take, maybe between 8 to 14. But you have 32 classes you get to take in college. And so what Bolu talked about of like, he took one anthropology class and then he was like, wait, I like this, and took another one. Well, both of those count towards his major. So he didn't have to start all over, right? So as you're exploring your interests and you realize, hey, I'm really enjoying this and I can pursue this, those already count for your major.
Okay, that makes sense. So as long as it's kind of within that same area, you're kind of good. All right, Paige, is there any other questions?
Yeah, I was just kind of wondering, we didn't really touch on, what does daily life in the lab look like? I mean, is it all fun and games? Is it frustration? What do you do on a typical day in the lab?
So right now I'm at the point in my PhD where I'm not taking as many classes as I was in the first few years. So I guess in the morning, I look at my experiments from yesterday, I write down the results of those. So because I'm in microbiology, usually things grow overnight, and then I'll sit down, plan my experiments for the day. A lot of my work is what we call at the bench. So I'm working with pipettes and test tubes and chemicals and liquids and bacteria. And so a lot of the time I am wearing a lab coat and I am, writing things down and doing experiments at the bench. But then another good chunk of the day is I can only contribute to the field if I kind of have a sense of what's happening in the field. And so a big part of that is reading what other people are doing in the field and learning from them and learning their protocols. So I do try and devote a certain, like every hour of the day or so, to just going through the headlines in microbiology, like what are the new discoveries? What are people talking about? And that is something that keeps me connected to the field and also helps to give me ideas or inform my future directions. We have a coffee maker in lab, so I'll grab coffee a couple of times. Sometimes I'll call Kevin and we'll get lunch together. And then I go home, usually around 5, 6 p.m. and chill.
So does your instructor, your professor, tell you what research you're doing, or do you have to come up with research?
It's a bit of both. So basically you have like a research advisor, or otherwise known as a principal investigator or PI, and they kind of set the theme. And you talk with them to decide within that theme of research, what you're really interested in. But day to day, and this is my favorite part about science, is that no day looks the exact same. And it's really kind of a choose your own adventure type of lifestyle because, well, one, things can go wrong and you thought you were going to do something and then it didn't work overnight. And so you can't do that thing and you have to pivot and find something new to do that day. But also because there's so many directions you can go into, you have to sit down, think about your work and decide where to go. And so a lot of that happens on the individual level. But you have periodic meetings with your research advisor and they help to guide you and suggest experiments or suggest, why don't you email this colleague of mine? They might be able to help you with this question. And so there's a lot of self-driven. By the time you're in graduate school, you have a lot of self-driven research. In undergrad, my experience was a lot more, my PI said, why don't you try this experiment and then get back to me and we can talk about it. So it was a bit more directed. But even then I was still able to learn how to start designing experience because he kind of helped me up the steps of independent research.
I think the only thing I'd really like to add is that when you're in middle school or high school, you might notice differences between your teachers in terms of their teaching styles. And some teachers might be kind of like, right behind you, kind of constantly giving you some feedback and support and telling you like how you're doing on some homework. And other teachers might perhaps give you some more space. And I think the same thing happens with our advisors, right? There are some advisors who will dictate exactly what experiments you're going to be doing moving forward. And then there are some bosses who you don't see for a month or two, right? Those are two extremes. I'm personally more in the middle. My boss, we meet every 2 weeks. And so I've got 2 weeks where, kind of like Megan said, every day looks different and it's completely up to me what happens. And I have the chance to just take these 2 weeks, try a bunch of things and show up to my boss and throw it all at him and say, this is what happened. And we talk it over. He gives me some advice and he helps me figure out some of my experiments, but a lot of it is just taking the feedback I get and formulating it into something that I can do in the span of 2 weeks before our next meeting.
So I think we're kind of getting towards the end, the end of our time. Jim, do you have any final questions for them?
I think they kind of hit everything really well.
Yeah, they did. Can you guys each give a piece of advice? And Megan, I'm going to put some extra pressure on you. You know, girls out there that want to be the scientists. Can you speak to them, please?
Yeah, absolutely. I think you need to believe in yourself, and you will believe in yourself when you find your passion, because it's going to be easy. You're going to think, I love studying this. I love learning about this. And you just keep working at it and you will be able to do it. And that's not to say that everything is going to be a walk in the park all the time, because I've definitely faced some things that have been roadblocks in my trajectory towards being a scientist. And I want to also be a professor like Bolu, and I look up and I still don't see representation, and that makes it really hard because I sometimes doubt myself too. So you can be at MIT and still doubt yourself and wonder if you're still a good enough scientist, but surrounding yourself with people who are good people, who support you, who are good friends, and who you can get a lot of help and advice from, and who trust you and support you, is going to be how you will succeed.
Thank you. Kevin, what's your advice?
So this is an important piece of advice regardless of where you go, but especially in science. Right. There are so many stereotypes about how scientists like don't write or aren't like, in the creative arts field, or like we're very like, narrow-minded in just science. And it's honestly just kind of, it's really inaccurate. We have to do a lot of writing as scientists, and regardless of whether or not you go into science, having the language arts skills to read and write and communicate what you're doing is so important and so critical, and I cannot stress that enough.
Thank you. Bolu, you get the last thoughts here.
I think something that like I'm still learning, but I started learning as I was finishing up high school and going into college, was that science is as much something that I learn and read as much as it is something that I do. And so even if my experiment didn't work, even if I didn't get the concept the first time, even if my equation is a little bit off and I'm correcting it, I'm doing science. And what that means for me is that like someone who does science is a scientist. They may not have to look one way or another way. They can have some kind of training and something else, and they're learning and they're helping each other. And like Megan said, really finding a really supportive community and surrounding themselves with that community. The act of doing science and thinking about science is what makes me a scientist. And it's something that I know if other students in the audience today are interested in and they want to do science, then they're scientists too, and they're working towards those. And going to college and grad school afterwards are some really great ways to make progress in that.
Fantastic. I think we do have one last question from the audience. It's just a quick shout out. On a scale of 1 to 10, how do you guys rate your experience at Harvard or MIT?
10.
10.
Yeah.
10, yeah. Best decision I ever made.
Yeah.
I don't know. I think when we were applying, we had like different places we were considering, and it was a tough decision. I'm really glad I'm here, and I'm really, really glad I got to meet amazing people like Bolu and Megan.
Well, Bolu, Megan, Kevin, thank you so much for sharing your time today and sharing your experience with our students. We really, really appreciate it and wish you all the best. And thank you for everyone joining us tonight. And we're going to go ahead and put this recording this evening on our website. So if you have friends or family that like to join in and hear about MIT and Harvard and research going on there and their experience, please direct them to our website. But thank you very much from everyone. Have a good evening.
Bye.
Bye.